Alright, so for our attachment to Bowie design, we chose to do a seat spreader. And our basic design for a prototype one was to base it off of, just your classic hand crank seat spreader. And we just got an idea of what different shapes and different design elements that will effectively work with it.
Okay, so these are all the parts that are composing our seed spreader. So one of the main parts is the wheel. So the wheel will be responsible for actually rotating, and it's attached to a motor, so it will rotate. And the seeds fall from this hopper, which is attached to this chute, which is attached to the motor mount. So this is actually where the motor will be mounted in. And we did a 3-piece design to reduce the printing time. And then we also have this mechanism on top, which is just a mechanical, manual way to close the holes on the top to just stop the seeds from falling through.
Alright. How Bowie will mount to, how this chute will mount to Bowie is from the back. We tested this, we screwed it, and did a good job of it. So far, our only concerns is the way the seeds spread. So what we are thinking that it could have some grills here to kind of spread the seeds more evenly. And yeah.
Cool. Thanks.
Discipline.
Okay, for what we're doing next with our design is we're gonna connect it to an Arduino. So the motor will be connected to the wheel, which will be powered by the Arduino. And we'll also implement a lid for the top and a mechanical way of opening and closing the grate. In terms of budget, our budget is currently about $70. We purchased almost all the materials we need. The only thing we need to really get is the Arduino, which would cost about $30, which would bring the total to just about $100. Okay, so we have some questions for you, Erin.
Okay.
First one is, are there any aspects of design that you dislike or require tweaking?
So, one thing I dislike is the visible layered delamination where the screws have been added here. So something that you could do is perhaps extrude another circle to make that flush with the face of the head of the screw. That way you're not trying to go into a curved face. Nice detail for preventing the fan from rotating everywhere. It's only rotating 90 degrees. I just don't understand why is this so long? Is that to just make it closer to the ground?
Yeah, so it's just to bring the wheel closer to the ground, so when it spreads out, it's going to spread out from the back. So we just want it to be close to the ground so it spreads out more evenly across the back.
Okay.
Instead of just falling down one space.
Right. For this screw, it's going to interfere with the other enclosure piece. So
I've actually test fitted it and it fits pretty well. It fits pretty flush with the Bowie.
how is that possible if this face is supposed to be touching that face? And there's a 3 millimeter protrusion here.
That part is just slightly underneath.
I'll just take a quick photo. Thanks.
Good morning, and we are A14, and we decided seed dispenser would be the great idea to rehabilitate fish areas.
Our product got lots of advantages. First of all, it's very cost effective because it's just printed by 3D printer, and secondly, it got a very lightweight construction, so it's very easy to transport. And the other advantages is it got a very long lifespan because some of the parts will last really long. And last but not least, it got very easy to screw on the robots. Just handle, but that's just our first.
So we made our first prototype out of cardboard to test the idea. So we learned from our first prototype, and we decided that the SolidWorks is more practical and scalable, and we can easily mass produce. So we became more added at SolidWorks, and we fine-tuned the specifications for our final product.
And the best part about our robot is, depending on the speed that the existing robot's moving at, the mechanism is made such a way that the rate of dispersion changes as the speed of the robot changes itself. That has to do with the wheel size itself. So the benefit of that is you get an even spread regardless of how fast the robot's moving, and that's been taken care of. Now, for the choice of seats, the customer can, depending on the geographical location and also depending on where, if it's a beach area or the climate, they can choose the type of seat that goes into it. And our mechanism is made keeping in mind what like different types of seats that's best for this particular idea. And here's just a cross section of our module here that shows the seat dispersion mechanism. Our first prototype is made out of cardboard. Right now, we're coming towards our final prototype, and it's going to be 3D printed, and we have provided you components for it. Do you have any further questions?
So this piece with the 4 extrusions is what attaches to the wheel, or the
So
what?
So those 4 things, it's to churn up the seats, and that mechanism would go about here, which is attached to the main axle. And depending on the size of the wheel, it correlates with the speed that the robot's going, and that again has a ratio to how fast it's going to churn, and then that dictates how much seat gets dispensed.
So depending on how fast the robot is going,
Yes.
what transmits the power to your design?
So how fast the robot's going means so this wheel mirrors the speed of the robot's wheel, and that drives the axle. So the faster it's going, the faster it's going to churn, the more seat it's going to displace to be dispersed. So it's a simple mechanism. It works every time. Less components, less chances of it having breakdown. So it's meant to be solid and working every time.
Okay, well, my concern would be that
We would love to have more of your feedback.
you know that the robot moves really slowly, right?
Yes, we do.
Okay.
Right, so good morning, everyone. I'm Thomas. This is Hamza, and that is Alec over there. We're group A15, and for whatever reason, our PowerPoint isn't coming up. But
this file's not on here anymore.
Oh, it's not. All right. Well,
he's gone.
Our project name is Spread'em, the original, seed spreading concept that none of you have seen before. It's passive, like some of the other systems that you've seen actually as well.
Yeah. Our design focuses mainly on a very, very low footprint for the actual design. Our footprint that the passive system is going to take up will take up only the area above the wheel. So as you have the prototypes there, we have a 3-to-1 gear ratio. The larger gear is going to be connected to the wheel, connects to the smaller gear, which goes up to an axle, which then connects to the spreader. That's going to be mounted on the side of one of the sidewalls, and then those are going to be what holds the axle in place and lets it spin freely. And then we're currently designing a hopper that allows for it to spread on both sides, so that way when we draw power from the wheels, we don't make Bowie turn one way. And also we want the hopper to kind of remain a center of gravity in the middle of Bowie, rather than being 2 separate ones. If you deplete one side, then it'll be more weight on the other.
Also, a concern in the client meeting had been that the load or the torque on the wheel that was required to turn the spreader would slow Bowie down. But we've worked on creating like frictionless or close to frictionless connections between the actual components and the spinner and lightweight materials, all of which are 3D printed. And as of right now, we've incurred no cost in producing all of our prototypes, and we hope to stay that way till the end. That's pretty much all I have. Yeah.
Any questions or feedback?
Okay, the first question is, how did you do the frictionless thing?
So what we've done is we have, coming up the side, we have, it's not frictionless, but we have like very, very loose fitting connections on the axle that runs up the side, which have a small, like, what's it called, acrylic coating on the inside, which keeps it from, like, it spins very freely. And so we in our testing, and this is something that we looked at when we had those initial gears, like the smaller ones, it was pulling a lot more on the wheels, so we found that the newer versions, it makes it, you know, a lot easier to spin. Again, we haven't had actually like a Bowie to use it on, but just like playing with them in our hands, we can feel a sizable difference.
Okay. It's hard for me to visualize right now how exactly it connects to the wheel, but that being said, the choice to do 3-to-1 gear ratio sounds very wise because the robot moves slowly. Yeah. So you actually want seeds to be spread out rather than just like dumping them all at once, because it would be attached to the same gear ratio. Anyway, I like the choice of your gear tooth design that uses 3D printing great, which is one of the benefits. So that way we don't have to have the standard type of gears anymore that have more force placed on the teeth. It will be great to see the CAD model just to understand it a bit better.
Which we have in the presentation.
Is the computer not working for everyone?
We had it on a USB that was on there, but that USB is no longer on the computer.
USB key here. Got 36 seconds.
Okay. We can send it to you, but it mounts up the side of the robot, and we feel that because it's high enough off the ground, the seat should be able to fall a sizable distance and therefore actually.
And as for the connection, the wheel itself has an inside part that connects to the actual motor, and we are using the 5 pins that are on the physical wheel.
Great.
And so we're going to be adding pins to that gear, and then those pins are 17 millimeters in a pentagon, like 17 millimeters per side, and then we'll add those 5 pins to the center of the gear, and it's made to be 2 millimeters less in diameter than the wheel, so it'll never touch the ground.
Or PowerPoint presentation. Start here. It's frictionless.
Yes. What a great solution to this problem.
So our group is making another seed spreader. What we're doing is we're attaching a 3-wheel trailer to the back of Bowie, and it's being attached using vacuum tubes. And the seed spreader contains 2 parts, a frame and so we have the frame and then we have the box. The box contains the seeds and we put it into the frame, and the frame is what attaches back to the back of Bowie using vacuum tubes. And in the frame there's a hole that seeds will fall through, and it'll hit a gear that's spinning with the axle to spread the seeds. So it's not just dropping into like one spot. But the problem is we don't know how to close the hole.
Yeah, so our biggest problem was having to close and open the hole where the seed spreads. So we could do that somewhat more like automatically or like wirelessly, something that would work well with Bowie. So our solution to the problem was we decided to have a remote and a wireless receiver and transmitter to do radio waves. And what it does is that it controls through Arduino, a DC motor that turns and opens a platform. Basically, the motor rotates a platform, and that opens and closes, which allows it to work with Bowie well. And it's independently powered, 12-volt battery that controls the Arduino and the motor. So yeah, and that's all we have.
Cool. So first question is, what's a vacuum tube?
It's like the hoses that you see on the vacuums.
Oh.
So that way when it's attached on, that the trailer can rotate with the Bowie at the same time.
Right. So is there a 3D printed piece that also attaches to the tubes?
Yeah, so we're gonna mount like a piece at the end of the tube and then a piece on Bowie, and that way it will like snap in, so it's easy to install and to detach whenever it needs to be used.
Interesting. Yeah, that might be a pretty cool solution instead of springs, maybe. Because with springs it may like go longer, but with vacuum tubes, then it would at least have that material constraint that it can't extend even further. The third wheel for turning, do you think that's going to work? Especially in sand?
The third wheel isn't really for turning. The vacuum tubes will turn with Bowie, so like when Bowie turns vacuum tubes.
Oh, yeah, sorry. What I meant to say is when Bowie does turn, will the third wheel pivot at all?
The third wheel isn't hitting the ground at all times. It's to prevent the trailer from falling backwards. So if it does fall backwards, it'll hit the third wheel like a training wheel on a bike.
Okay.
We made sure to use a higher gear ratio as well for when the wheels turn, so it's a 3-to-1 ratio with the bevel gears.
Great. Yeah, and also good choice with the gears for 3D printing. Do you have any questions for me?
I guess just like overall what you thought of the design, like how we like maybe like open and close the platform, how we like disperse it.
It wasn't clear to me exactly how it's being opened and closed, but it sounds like you came up with a solution, so I'm assuming that that works. Another concern that I would have is probably just the weight, so it looks like a really big container.
Yeah, the prototype was too large, we're shrinking it a lot.
Okay, cool. And apart from that, it'll be great to see like if you can 3D print some of it by the time of the demo day, design day. Yeah, feel free to email if you run into any further road bumps.
Excellent, thank you very much.
Hello everybody, I'm glad you could all make it down here and listen to my presentation. Thank you Aaron for coming to give us some customer feedback. Without further ado, I would like to introduce you to Robot Mobility System Initiative, or RMS. Regarding your concerns about consumer base and gathering it, we've decided that in order to improve Bowie, we should start with its foundation. You had some concerns about being reliable in different applicable environments and having some issues with wet sand. So we've decided to make some improvements so we can expand its horizons.
Oh yeah, so what that means is that we're going to focus on improving Bowie's ground actuator. So based on market research and some test data, we've come to converge that robots with similar size to Bowie have actually been able to increase its weight that they carry through one historical trend, and that's with the utilization of tank tracks. So our structural design will employ the readily available materials that are 3D printing and rubber polymers, and we're going to make changes to 3 sections. That being its attachment, its rotation, and the contactor surface. So for the attachment, we're thinking of, to increase user experience, we're going to reduce the 4 screws that you have already to 1. For the suspension, we're thinking if we use state-of-the-art designs for like wheel discs, we can enhance Bowie's like ability to be introduced to new environments and sort of overcome those landscapes. And for the tracks, we're thinking of using like motor fan belts and 3D printed clip-on serrations so that during its use, whenever they're becoming, let's say, worn out, you could replace each one at a different time instead of replacing the whole piece as a total, right? So we're just planning on making it a better like business solution for you, right? So it's simpler to use, it's probably more effective, and when it's on Bowie, it's probably going to look awesome. So with this in mind, is there anything that stands out to you?
So definitely what stands out and I think is new is the idea of having the 3D printed clip-on serrations to the wheel. That'll be really interesting, especially for our Arctic field tests, because then if one breaks, we can just replace it on the fly.
Yeah, that was the aim. See, we initially had Ninjaflex. Actually, I'll let you.
We originally had Ninjaflex, and then when we tried to print it, we had difficulty with the machine because there's only 3 specialty printers that take Ninjaflex as their filaments. And it took us 7 hours to print like 1/8 of a piece. And then it didn't work either because it's just the filament
was around like 20%. And we're thinking that for you, if we were to use Ninjaflex, we'd probably have to push up to like 50, 60, somewhere up there just to get the sturdiness.
Yeah, so that is what we decided to go with the fan belt instead, because it's more lightweight, and it's just you can have one is more durable than this material, because this material is like it is flexible. Although it's flexible, it's very hard to print. Like if you want to buy something from the fan, like a fan belt or something like that, that would be very like $8 or something like that, and you can just buy it and replace it very easily instead of having to wait for like probably around 40 hours if you want to put 2 tracks.
Yeah.
Was there anything else? Sorry.
So have you tested the pentagon or hexagon design that you have with actual 3D printed pieces?
Yeah, we bought what was it, a bolt already, and we 3D printed a piece that accepts the thread, and it's been able to do it so. But with like a high percentage of filament.
Bay 20.
Yep.
Hey, so our attachment that we decided to make for Bowie was a seed dispenser, and we decided to go with a, I don't know, make another seed dispenser, but it's logical. We decided to go with a seed dispenser because Bowie's original mission is to pick up the garbage on the beach, so we decided to make a seed dispenser so that Bowie could pick up the garbage and dispense seeds at the same time. So he's not only improving the environment, but he's also adding on to it, which is just a win-win situation.
So our first prototype mainly is built out of cardboard, which allows us to further develop our future prototypes, since it is very easy to use cardboard, and we have also saved on our budget since we use $0 for this prototype. It is mainly constructed using 2 main components, which is the seed container and the move-in gear. The seed will be placed in the container and will be dropped on the seed, which in future prototypes will be moving using the help of an Arduino.
Yeah, so for the Arduino, so just a little, we didn't have a specific schematics for the circuitry, but close-up pictures right there, it's also just down here. It's just a really simple circuit, transistor, 270 ohm resistor, and a diode, just connected to a 6-volt motor that we plan on spinning see here, just a little gear-shaped object with little containers and holes for these seeds to get placed into as it rotates. And that's basically our simple idea for how the seeds are going to get dispersed. And so big improvements to make upon this for our next prototype, for our final product. A few things. One, we're planning on lowering the size and decreasing the size of the gear that actually disperses the seeds just a little bit, because it is a little bit big right now. 2 would be just the wiring. We're going to clean up the wiring on the circuit. And 3, the third that I could think of is at least making sure that our motor does work, because right now we have a 7.2 volt motor, which is just too much. So we plan on dropping it down to a 6-volt motor, which should work.
If you want to see the gear that we 3D printed, so those small holes are basically the containers for the seeds to go into. And as it turns, the seeds fall, and then it gets filled up again, and it keeps turning. And we'll have like a tube going to that gear from the hopper, and it'll be close enough to the gear so that when there's no open hole for the seeds to go into, the seeds won't go in and they'll wait. And our end goal is to make the gear rotate with Bowie's wheels, so that if Bowie stops turning, the gear stops turning, and there's no seeds being dropped on one spot.
And our plan with that, by the way, it's I want to try to get it with the whole circuitry and with the Arduino program. I want to try to make it so that we can use the controller and we can let the user kind of adjust the rate at which the motor is turning, as well as a toggle for on and off, because if you want it just to sit still while picking up stuff, you don't want it to be dispersing any seeds.
1 minute.
So yeah, that's, I think, the gist of our presentation.
Okay, so you're powering it passively, then can you inform me again what's the purpose of the DC motor?
Well, we're using the DC motor just to spin the gear-shaped thing, which is going to be basically the seeds are getting dropped into the little gray gear-shaped object you have right now, or the containers, and the little holes in the side. So the seeds are getting dropped into there from the hopper, and it's going to rotate.
No, it's vertical. It's vertical. That's what you're wondering.
Yeah, it's vertical. So they're going to be rotated out of it. Yeah.
Like this here.
Okay.
Like that. It just goes like this from the back, and then it just continues.
And we'll attach the whole thing using a dovetail onto Bowie. You can attach on any side.
Okay.
And you can have multiple ones for different types of seeds at the same time.
Yeah.
It will be great to see a CAD model of this. I'm a little confused, but nice progress.
That was 821.
So essentially what we're making is a seed projectile. It's not a seed dispenser. What it is for water. So it's for lily seeds and also fish food as well. We've looked into lily seeds in Ottawa, and there is actually a native lily seed here called the hardy lily seed. So what happens is, this is just a smaller scaled down prototype. So what's essentially going to happen is seeds will be loaded into here, and we'll have a servo motor, which will have a latch to open and close it, so seeds can be evenly dispensed into here, because if not, it'll just fall down continuously. So this is going to spin with a DC motor, and essentially what's going to happen is it's going to fall into like a tube with a fan blower, like a small 9-volt. It's a 9-volt, so it might need to be externally powered. But essentially, just going to blow it, and it's just going to spin and shoot into the water.
Wow, okay. I really like how you did the research on what lily seeds are here in Ottawa. That's great. The idea of projecting fish food is interesting. Sorry if I misheard this. Are you powering it with a DC motor, or are you powering it passively?
We're powering it with the DC motor to spin this, and we're also powering it probably external to power the fan.
Okay. So how does it do the whole projectile thing if it's just...
So we haven't actually added on because the part is being shipped, so we kind of want to get the specifications. But for a CAD model, we're going to design it as like a tunnel. As a wind tunnel, it's going to fall into here, and it's just going to blow it and push it out. So it's going to be like a vacuum for reverse.
So like an air cannon thing, it blows air and then it... Interesting. And how powerful does that have to be to do that?
Well, this is a bit smaller, but we designed it so we specifically have the volume in each notch to generally we can make a fan that, or get a fan that had the right amount of weight, force, to shoot out whatever would fit.
Okay. Nice. Yeah, so that was actually calculated.
Yeah.
Great work. When do you get to test it?
Whenever the fan comes in, and that should be simple.
Okay.
But we tested the spin, and
nice.
We just need to work on the fan aspect of it.
And how does it attach to the robot?
So we're thinking stuff like
It'll just be on on top, and then basically just orient it towards whatever you're trying to get it at. And it's kind of like a shotgun approach.
Yeah. Okay, I can't wait to see this in action, especially for demo day. Maybe you could do like a demo with like Skittles or something, I don't know. But with the seeds, that's great. This is going to be interesting. Thank you.
Okay, so we're group 22, and for our attachment for the Bowie, we're making a module that cuts weeds, as well. Like we're hoping that we can use in the future to cut the stems of fruits that they can drop from like low-hanging bushes or trees or something similar to that. The reason why we decided to make a weed cutter was because they're harmful to the environment because they can take up nutrients from competing species around, and it's also just aesthetically unpleasing.
Yeah, so like certain weeds such as nutgrass release chemicals from their roots which are harmful to surrounding plants and can cause allergies to humans. And aside from that, it also negatively impacts the aesthetics of gardens and parks.
So because of the negative effects of weeds, we decided to create an arm that removes the weeds. So basically, it attaches to the front of Bowie, so using the dovetail, so it just replaces the current arm that removes trash. And basically how it will work is that Bowie will approach a desired plant and adjust its position manually, and then using this scissor-like mechanism at the top of the arm, the weed will be cut successfully.
So we will also be implementing a safety measure to avoid dangerous activity. So our module will know when to release its blades if there's any strain or excess strain on the motor. So this will help, of course, avoid hurting people or even malfunctioning the module itself.
So the arm is to be manually controlled by the user using the Bowie remote from your designs, Aaron, as well as a few alterations to its code that better suit our functionalities for the design. So with that being said, with our design, environmental restoration is easily possible with the removal of weeds. So yeah, that's our presentation, and we'd like to know if you have any questions for us.
Also remove the red part.
Yeah, that'd be great.
Like this would be the servo would go inside there.
So the way the scissors work is that a servo is attached to just regular scissors.
Yeah. So like it would be like kind of modified pair of scissors, would be kind of like cut off the end. So one would be a fixed blade, and the other one would be attached to a servo, which would rotate.
Right.
And break like that. Pretty much. And there'd also be a servo in the the middle part there, so we can adjust the angle of the blades as well, and like the height of the entire arm, so we can cut pretty much anything at any angle.
So essentially, just replacing this scoop with now this. And
pretty much.
Yeah, great. If you were able to, would you add, say, a sensor on it to detect if there was a human in front or something that you wouldn't want this to accidentally
because
harm?
now, because Bowie still kind of manually operated with the remote, we were assuming that the driver of Bowie has enough sense not to cut a human or something similar.
Yeah. Yeah, so maybe potentially in the future using visual recognition. How are you going to test this?
So we were thinking of really just getting stems of weeds, different plants, and then just cutting it, seeing what works, and making whatever alterations we needed.
Okay. Yeah, good work. I can't wait to see it cutting things. Cool, great.
last one.
So we're group 825, and we are also producing a spreader. Our first prototype was similar to a garden spreader you would find in a hardware store with a spinning disc. And for our second prototype, we decided to actually change that spinning disc to a remotely controlled positionable slide. We envision our spreader being having a multifunctionality aspect to it, with the ability to spread seed or even salt for icy conditions, icy pathways. For this to be effective, we would have to remove the hopper installed on Bowie currently, and possibly the arm to increase our carrying capacity for seed or any other sorts of particulates.
So we reduce the risk of failure by simplifying the components. We also believe that our model will be a less maintenance system that will be less likely to jam.
We were just wondering if, based on our visual prototype and our description of what we want to do, were there any issues you think it might have, and if so, what issues?
Okay, so the chute is to change the direction that the seeds fall?
That's right.
Yes.
And ideally it extends past the wheels so that it doesn't interfere with any of Bowie's parts.
Also, with our current designs for the chute, the chute won't, the base that the seeds will be flowing down won't be flat. With our current design, it'll have spikes, although if that doesn't work, we do have other ideas. The spikes, or the replacement, will cause the particulate to spread out as it's going down the chute.
So it spreads evenly by the time it reaches the end of the slide.
This is a different approach, so that's interesting. So like, you'll be taking a lot of seeds at once, sending them through this sort of game-like machine with all the spikes, and then hoping that that will like disperse it.
The flow rate will be able to be controlled. There'll be a door that opens up from the reservoir before it falls to the slide.
Okay.
So that you can control how much seed or other particulate will fall out onto the slide.
We originally, like other groups, had the spinning disc idea. However, we figured that with our first prototype that there might be a few issues with it. It's definitely a more complicated design. There's the issue of getting the disc to spin fast enough to distribute the seed, as well as sort of clogging issues with particulates getting caught underneath the disc.
Right. Concern right now would be just time-wise. Demo day is coming up pretty quick, so you might want to.
We do have SolidWorks models of most of the major components.
Okay, great.
You're also wondering what your opinion was on the multifunctionality of the spreader, as far as salt or maybe something else like sand or something.
Yep, multifunctionality is important.
Could you see this application being used in the winter time?
I'm not sure yet, because it's a little unclear to me how exactly it's all together.